your solution to it. Haven't you ever wondered, like, how to save some gas, when you're driving your car? That's right there.
So it brings up a really good point. You always want to remind yourself what the hell the end result is supposed to be, what you want to do. Because it's really easy to get halfway through a problem and be like, okay, what? Especially a problem that has very few numbers in it. You just can't relate it to anything. So the whole purpose of this was to try to minimize the velocity. So all I know about this is it's a critical number for the first derivative. So it's a possible minimum, but it's also a possible maximum. It's also a possible trick thing, right?
So is L in this case, if you're trying to find velocity, just L is just a random variable?
So we're trying to figure out what the length has to be of the wave to make the velocity a minimum. So what's my input have to be to make the output smallest? Right? Yeah.
So since it's L equals C and you're trying to find the minimum, you wouldn't choose a value lower than that? You wouldn't do
if I want to see if it really is a minimum, I need to look around it and make sure everything else around it looks to be bigger. Then that would be a minimum. So I've kind of, like I said, I've kind of forced it to be an easier problem, an absolute question. If this is the only turning point, I could force it to become an absolute max or min question. Because those are easier, you guys should remember that. Absolute questions like kick ass. You just find the critical numbers and plug all the numbers in and just see who wins. That is so much better than finding all the critical numbers and seeing what's happening at each one. Should be able to do that, but that's definitely a little harder. Yeah.
On number 2, for the
let me, real quick, I'm sorry. Let me finish out the other one. So that's the first one that wasn't on there. And then I think 60 was the other one. Oh, yeah. So I keep talking about profit and stuff, and I am not a business person. That is for damn sure. But I figured I should give you one problem at least with this in there. So the cost, number 60. The cost is there. Oh, 0, 0. And the demand function is this. Okay. And revenue, this demand function they talk about, that's the price. So revenue, and I think this is in section 4.7, right? They have an example. There we go. Yeah, okay. So at the bottom, page 330, they have an example about this. But they call this the demand function, but it's really the price function. And the price depends on how much of the product is out there. So the revenue is really just going to be the number that you sell times the price per. It's almost too simple. Part of my brain is saying, you're teaching business. Shut up. I don't like business. So, I mean, this is almost too simple. I mean, the price per times the number that you sell is the revenue. How much money you take in. So that's just going to be 48.2x minus 103x squared. So they say graph those. So you just graph those in graphing calculator. And they got the little graphing calculator symbol. Use calculus to find the production level for max profit. So now you want to maximize your profit. Well, now, even without any business background, maybe some of you guys do have it. Profit is what? Profit equals money. I love it. But be more specific with what I got written up there.
It's the amount.
Revenue minus cost. I love it. The money you take in minus the money you put out. And you hope to God it's positive. Right? In recent times, you hope to God it's not so negative. And then you're happy. So profit would be revenue minus cost. So I get, ugly crap. Let's see. 40.2 minus 25x is 23.2x minus So it'll be 0.2 minus this, so it'll be 0.17x squared. Okay, good. Got that and that taken care of, and then it's just going to be minus.
They're both negatives, aren't they?
I'm subtracting this from this, so I actually got to change all the sides.
Okay.
So now it's going to be minus 1800 minus 0.001x cubed. I think I got everything in there, right? Put these together, put that there, bam. Okay, cool. All right, this is almost, you just got to combine those functions. So now I've got the profit function, now I can attack it with calculus. They want me to try to, incredibly enough, maximize that. Sounds like a good idea. Is that cool? I mean, from here on out, it's easy enough. It's just ugly numbers, but you got to.
So you subtracted the CX minus the PX? But then you
Well, the profit is revenue minus cost. So just this minus this. Yep.
Would you give us something like that?
If I did, I would actually put this relationship down there.
Okay.
Yeah, it's not a big deal. I don't want you to feel like there's some business part of this course you missed or something, right? It might sound like it's more involved than that, but that's all it is. Yeah.
Sure.
Okay. Estimate the production level that minimizes the average cost. So then you just focus on the cost itself to minimize the cost.
Well, then so you just take the derivative of the cost and...
Yeah, exactly. So you can, there would be situations where you don't necessarily want to make the max revenue because the cost might be too high, and some of those costs have to come before you've made any money, and you don't have any money to pay those. You kind of with me? So you might want to look at the cost and minimize it, and live with whatever revenue that means, because you can't do the upfront stuff. I mean, it all depends on, and that's where the business courses can take over. I'm just here to give you the tools that you can then use whenever the hell you go there. Right? That's as far as I want to go into business. Well, whatever function they reference, maximize the revenue. Okay, I'm just going to focus on this function. Cool. Now, I'm sorry. So let me get your question and then your question.
Okay, no, it's a really quick one.
Yep.
So number 2 on the answer sheet, I don't know if we made a mistake or maybe I'm not seeing it correctly. On number 2, right where it says f prime, it says 2x times x plus 3, and then you added it. Were we supposed to multiply it, or?
So what did I do on number 2? What did I do from the first step to the second step? What did I do?
Factoring.
Factored. Cool. I factored.
X will be negative.
Click using x plus 3 on both sides of the plus sign.
Px.
Here?
Yeah.
It's possible.
I don't
understand
You can
what's
make any
happening.
money on it.
If we make it px equals to 0, I think it will be negative.
Yeah, maybe it's possible that they don't make any profit at all. So then the maximum profit might be negative. I don't know. I didn't really look at it, but you're right. The minus 1800 really kind of brings it down a bit, doesn't it?
Like even if you make 0 of them, you still have that 1800. So it was like just talking about it costs you money.
Squared. Yeah, okay, so I put those together. Yep, okay. Yeah, sucks, man. So that's the real world problem. Yeah, maximize your profit, which means make it as least negative as possible. Okay, but do you understand? Is that number 2?
No, can we just do just take the derivative really quick? So I can take
You already take the derivative?
Yeah.
he did it on there, just
What
Number-
was that from?
number 2.
To finish that problem, all we would do is just
Where's
take
our
the
initial
derivative.
function?
The initial function.
Oh, this. Yeah, p prime. Take the derivative. Set equal to 0.
3.
It has a little calculator. It has a little calculator symbol, thank God, which means you're allowed to get what you need from the calculator itself.
You can't like look at a calculator.
You still want to use calculus. They say use calculus to do this. And actually, if you take the derivative, you're going to get a quadratic, right? So then at that point, you use a quadratic
for 0.
Yeah.
And then you just pick the one that's not negative, right? Or if it's a quadratic, or there's necessarily negative. Never mind.
They could both be negative, yeah.
Px equals to 0
Oh.
Which point you
0?
shoot your boss, steal all the money, corporate accounts.
Move to y.
All right, so real quick, on number 2, the function is, what was the function?
X times x squared.
So if I take the derivative, it's 1 times this,
Right.
plus x times the derivative, this will be 2 coming down. That's to the first power. And then I know that I want to find the critical number. So I know I'm going to set this equal to 0. I am not going to do anything that tears things apart. I'm trying to, let me say this a little more careful. I don't want to square this. I don't want to FOIL this, distribute this, because I've got that repeating. I always want to look for that. I want to go towards factoring. If I break things up, like you guys learned on that quiz a while back, that's a horrible way to go. Because you might end up with
I see what you did.
way too high of a power, and then you got to use synthetic division to try to just screw that shit up. So don't go far away. You've already got common factors. Take an x plus 3 out, so now I'm left with
X plus
1x plus 3 there,
plus 2x.
plus 2x.
Okay.
So now I see what you saw. You're like, what math magic did you make to make 2x times that become 2x plus that? And I didn't. It's just the way it happened to come out.
Yeah.
That is weird. I didn't even notice that.
All right. Great.
Okay. So anything else from homework? Any general ideas?
Okay, so looking at number 5 on the practice test, 5C, we have, I think, infinity times 0, unless I'm looking at that wrong. And just because E repeats, I think you get something weird. Are you supposed to go until your x's run out? But I don't know. I'm just wondering how you attack that, unless I'm looking at it wrong.
So 5C?
Yeah, because the E repeats, I think you keep getting the 0 there, right?
But the nice thing is, what's the first step on that? What L'Hopital's requires a ratio,
Oh, yeah.
right? So then you bring that down,
Oh, that's why it is.
and then the top is a polynomial. It's going to eventually disappear. So you almost don't even have to do work. When you get to a point, you have to do a couple L'Hopital's, and you start to realize, well, e to the x is going to kill anything. Any polynomial is going to die because of what you just said. It's going to be itself forever.
Right.
So if you have something on top that's eventually going to die, hey,
Okay.
it's going to go to 0.
For
Yeah,
some reason I'm doing product rules, that makes sense.
crazy. Can't do that. Yeah.
Can we do number 60 on number 4.4? I mean number 60 on 4.4.
Oh yeah, that looks freaky. Let's see.
I just say 2x to the x.
60. This is 4. This limit question here, right? X to the ln 2 over
1 plus ln of x.
1 plus ln x.
Equal to y take your natural log.
So, a little side work. If y is x to the ln 2 over 1 plus ln x. Well, I don't even know if I have to do this work. So, if you take the ln of both sides, this is going to come down.
What is that? Y equals x times the natural log, or x to the raised to the power of natural log?
Raised.
Raised. Okay. That's,
And then where can you go from there?
The natural logs cancel.
So first off, see, what's the real problem here? I mean, the real problem is you got x to a power. This is getting very big, and this is getting
Really small.
very small. Cool. So what you really have is like infinity to the 0, which is an indeterminate form. Now they have a whole little section devoted to that form on page 306. And the next step here, you don't even have to do all this. The next step here would be e to this. And the reason that is because I want you to see the difference here. I'm going to give you a very stupid, simple question, but there's a point to it. What's that?
E to 3. It said constants.
Yeah, it's e to the 3. I love it. So you're allowed to go in there, right? It's exponential is a continuous function. You're allowed to take the limit into the function, right? The problem here is this and this. You can't quite just skip over this because it's being affected by the limit. You with me?
Yeah.
So by rewriting it in terms of e to this, I can now say, okay, the limit. And I want you to realize something. I didn't do anything. This is the same thing. These are equal to each other. And you should know that little trick. If I have x to the what do I want to say, x to the m or something. Let's say x to the u. Why not? I can rewrite that as the same thing here. I can rewrite that as e to the. I don't know if you know this.
U, L, and X.
U, L, and X. And it's not even that big of a deal. E to the ln of x to the u, wouldn't this just cancel? Isn't that the same thing?
Yeah.
But what can the u come down if I don't do that? The u can come down. Right? So really, I just rewrote x to this as e to the ln2 over 1 plus ln x. Ln x. Now I do have it. Now if I bring this in there, that's a L'Hopital problem because now it's a ratio. Right? So if I write a little bit, now this is going to be e. This equals e to the limit ln2 ln x over 1 plus ln x. And the really funky thing, do I still have an indeterminate form in there?
Right now, it's still indeterminate, right?
Yes, because what is this?
0 over 0. Oh, it's x to infinity.
So you can attack it with L'Hopital's, but, well, let's see what we get, and then I'll show you why you got what you got. So what would L'Hopital's say, what happens here?
ln2 over x over...
Good, ln2 over x is a constant, times 1 over x.
And that's going to be over 1 over x. Which is multiplied.
So the x's cancel.
Yeah. Let's get...
So I get equals e to the,
Natural log of 2.
which is crazy.
Holy cow.
So right here, do you notice, what's the degree? This is a very strange question. What's the degree of the top and bottom? Or how do the degrees relate? That's even a better question. They are the same. They are, if I ask you what degree they are, is it? But they are the same degree. They're both being natural logged. So it's actually a neat extension of the ratio polynomials idea. ln is very similar to a root in a lot of different ways. So it actually can be seen as a certain degree. So it's going to be the ratio of the highest degree terms, ln over 2 over 1, which is what we got, ln 2.
Holy cow.
Do you have to see that? No, because you just do L'Hopital's and there it is. Yes, sir. Good.
How come you brought the e back over to the ln of 2?
I didn't. The e is just there, right? I rewrote that as e to that, brought the limit in. The e's there, the e's there, the e's there. This limit is ln2, but it's e to this. So it's e to the ln2. The e's there, I had to rewrite it so that I'm allowed to jump over this dude. I can't jump over this dude, but I can jump over that dude. I can bring the limit inside of a function. But I can't bring the limit over an x. The x is being affected by the limit also.
So how do you get rid of the x? That's what I'm asking.
Yeah, this way.
Okay.
I didn't get rid of it, I just wrote it in a different form that on first blush is like, that looks even worse, what the freak? But the reason that it's better is because I can jump over that. I can bring the limit inside of it, and then I got a ratio. It's all a question of, you guys know L'Hopital's needs a ratio, and you're like, well, there's a ratio there, but what the hell do we do with that shit? Just kind of incorporates that in that ratio. It's kind of nice. Yeah?
Did you like somehow turn the X into an E, or was that there all along? I'm missing the beginning there.
This here.
Because when you take
That's what I asked. That's what I asked.
So I took an ln, which took it down,
Yeah.
and then I applied an e to both sides directly without really undoing what I did. I want you to really understand. So I took an ln to both sides, which brought this down here, right?
Yeah.
Makes sense.
Then I applied e and just e to all that crap without simplifying it to this.
And e to the L and y gets rid of the L and y side, so it just
Exactly.
makes it a y. Right.
Cool. So now it looks like it should be worse, but actually it's better because now I'm allowed to limit to
Well,
this
you
ratio.
But you just take the e out anyway because you have no need to. Right?
As long as it comes back in.
Yeah, that's what I'm saying. Yeah.
So on the part you circled right there, what step did you do in order to get ln 2 over?
So it cool with what happened from here to here?
Yeah,
So this is a number.
right.
What's the derivative of ln x?
1 over x.
So then I get ln 2 over x.
Okay.
And then of course the 1 over x there. Right, because the 1 just goes away, so the x's die.
So what rule is on there? Is just product rule or?
No. This is just like 7 ln x. It's a constant times a function.
Oh.
So the constant comes with a ride, and the
Yeah.
function gets
I see it.
derived. Yeah,
Over
the whole's right. Yeah.
Can we solve 45, 4.9, and 60? So the untitled.
Oh, good. Somebody else was asking me about. We didn't do this one. I think you're realizing what you had to do. What was you calling? 45 gives you this.
Oh, yeah.
2. And then it gives you what they call. What do they call it?
F of 0 equal -1, and f of 5 over 2 equals 0.
0? Okay. So I think they call these initial conditions. In physics, you call them boundary values. It just depends on what the hell's going on. So the first step. So this whole idea, I think I've had bonus problems, and most of you guys have got it at least close to right, if not completely right, because it's not a big deal thinking backwards about derivatives. We've talked about it a little bit. We talked about it very directly here recently. So if I do one underivative, yeah, so that must have come from 2x. That must have come from sine. And of course, you don't forget the c. What number is this one? 45. And 4.9. Now, I don't have any information about f prime. That's too damn bad. I gotta keep going. I only have information about f. And why do they give me 2 pieces of information? Because I'm about to get another constant. I like it. Or, yeah. So if I do one more backward step, this is nice.
X squared.
X is squared.
This is a little freaky, maybe. Good. Minus cosine.
Plus CX
Plus CX.
Good. Plus cx
Plus D.
plus d. I like it. Yeah. Or your favorite letter. Right?
If we had like a third derivative, did we just tag on an e?
You could. What's even better is to call it C1 and C2.
Oh, okay, then you
In that case, especially when you get to, if you got to take differential equations, you're going to have C1, C2, C3, maybe C infinity, right? So you're not going to want to use A, B, C, D. You go a little crazy. A little crazy very quick.
restart after you hit Z.
Yeah. So now how do I finish this up?
We plug in f of 0.
Yeah, just substitute. So f of 0 is from this 0,
D.
negative 1, 0,
0, D.
plus d, and that's supposed to equal negative 1. So d has to be
0.
0. I love it. So then f of pi over 2 pi squared over 4 minus cosine of pi over 2 is 0. Plus c pi over 2, and we just figured out the d is 0. Right? So you want to use that information also. Yes, sir.
How did you get the f of 0 equals negative 1 plus d? You just plugged in
Oh yeah,
0?
just plug 0.
Oh.
F of 0 equals this, and from there it's supposed to equal negative 1. Cool. And this is supposed to equal 0, so now you just solve that for c. So pulling this over, negative, and then multiplying by 2 over pi, I'm going to end up with negative pi over 2. Negative. I think.
Is that a 4 on the bottom?
Here? Yeah.
Okay.
So then the function is, so you just put it back together. So f of x is x squared minus cosine x minus pi over 2x, and the d is 0. Very satisfying. And that shows that the derivative just gives me an idea of shape. These guys are kind of like pinning where the thing is, right? The derivatives give me an idea of shape. So that's why I do end up with this plus, who knows? It could be anywhere. All I know when I have the derivative is what it looks like, not where it is. And that's really another reason why I end up with these constants tacked on at the end. They're my y-intercepts. Depending on what the hell's there, they're my pinpoints, my anchor points. Tell me where this thing is. Yeah?
Could you do number 15 or 4.8?
15?
Yeah. 4.8.
Okay, so 4.8, number 15, this is Newton's method. Real quick, what's the format here? You guys have to know this.
X minus f of x over
No,
f of
x sub n minus f of x sub n divided by f prime of x sub n.
Okay, cool. So before you do the problem, you want to come up and make sure you got that right? That's cool. You can come up and ask me. I'll harass you a little bit and then I'll tell you. So for this problem, they want specifically the negative root. So that's kind of nice. They've given me a lot of information. There's only one negative root, it sounds like. To get an idea where that negative root's going to happen, this, of course, looks like what? You know what e to the x looks like? This looks like what?
So down problem.
So negative 1, negative 2. So at negative 1, this is going to be 1 over e, so that's roughly in between 1/2 and 1/3. All right, so we'll just call this, who cares? It's about 1/2. It's close to 1/3, who cares? So, this looks like, say it?
Upside down parabola.
Upside down parabola with the intercepts.
2, negative 2.
Yeah, 2 and negative 2. So it's upside down, and it's of course the vertex 4. So here's a positive root. That's not the one I want. I want the negative root. And it looks to be very close to negative 2. You guys kind of with me? Okay. So the sketch you make does not have to be pretty. And in fact, expect this to be a question I ask. And I know, I'm hoping that some of you guys don't just graph it. But you will, I don't blame you. You should be able to just get a feel for something with a very quick, rough sketch. Right? So I don't want those sketches to be beautiful. I want them to be ugly. So x1 is going to be...
Oh, hang on, I have it written down.
Well, we have to find the derivative.
Yes, we do.
Because,
But what's x1 going to be?
Negative 1.
I picked negative 1, but I mean,
From this picture...
negative 2.
Okay. But you're right. I mean, you're a good point. Depending on how your sketch went, you could pick who knows what. Right? So, as long as it's close enough, the process will bring it in. It's just that there's a certain, it's not really a certain interval because it depends on where it is. Certain areas that it can't bring it back in. So Newton's method is simple, which almost always means it's prone to very small things that will make it freak out. All right, so that's the trade-off. Simple means it's going to freak out easy. Like you said, what's my f of x that I'm actually working with? There's a couple of ways you can write this.
4 minus x squared minus e.
Yeah, you could do 4 minus x squared minus e to the x, or you could have stuck this stuff over there. Doesn't really matter. So then, what's f prime?
0 minus 2x minus e to the x.
Yeah, so that what that tells me is I would much rather have it be this. So I don't have negatives running all over. You with me?
Yeah.
And you can totally do that. The function just needs it to be, you want to set this thing equal to 0, because that's the whole idea of Newton's method, is finding the roots. So I can bring this way, I can bring that way. If you end up with something, a bunch of negatives running around, which is an easy way to get confused, get rid of the freaking negatives. Take it the other way. Now setting this up, xn plus 1 equals xn minus, on the top here it's going to be xn squared plus e to the xn minus 4. Is this cool?
Yeah.
Just, and on the bottom it's going to be 2xn plus e to the xn. So then x2 will be x1 minus, x1 squared. Oh, screw it. This is where you can start doing it all in the calculator. So, this will be 4 plus e to the, and you still are just going to do it, aren't you, Jeff? Over negative 4, plus e to the negative 2. Freaking. So whatever the hell that is. But is everybody decently comfortable with the automation, how you can keep that in the calculator and
Doing the
automate?
answer thing.
Yes, the answer thing. So if we try that out real quick, which one are you dead? You are.
Giving you dead calculators. Counterproductive.
Huh? No, they become dead over time. And then I
Forget.
bring them back to life. Someday.
Someday.
So you put in there negative 2 to get started. Then you have your answer, and wherever you see this xn, you put answer. So answer minus parentheses, so that some of you guys are going to get caught by those freaking parentheses. Answer squared plus, oh, this is exciting, e to the answer minus 4 divided by twice answer plus e to the answer. And that gets there pretty damn fast, right? I got negative 1.96498 for the x2, and then x3 was negative 1.96463, and then it was based. That's pretty much what it is. Yeah.
So what did you type in the calculator? Just that bottom function right there?
Yeah. So wherever you see an xn, replace it with ans, right?
Okay.
But you have to put in there. You have to first put negative 2 enter. So that starts off as the first thing that's in temporary memory. So wherever you see xn, you replace it with ans. Parentheses around the top, parentheses around the bottom. All right, because calculator can't see, not this one, maybe the TI 2000, and then, next step, we know what happens. Liquid metal and all this kind of, yes?
What do we have to remember overall for the test? Because I know there are some sections where you had to have, you just memorize some tables of information, I think.
Any derivative that you know, that I told you had to memorize. And an example of one that you didn't was the